Today in class, we began with a warm-up where we were simplifying radicals, including rationalizing their denominators. So I'm just going to run through a few example problems and try and hit all the different types of problems that you'll be experiencing in the warm-up so that you can complete it. So we'll start with 7 square root of 6 over 4 square root of 5. And in this problem, I look at my rational coefficients to see if I can simplify anything there. I can't. I look at my square roots to see if I can actually take the square root, which I can't. And I also look at the ratio or the fraction there made by the square roots to see if I can reduce that. And in this case, none of the reducing can happen. So this thing is reduced. I'm just going to rewrite it here so you can see our next step. So we always try and reduce first. I'm going to add that in here. Reduce first. So we try and reduce, and once we're done reducing, then we rationalize. And the way you rationalize it, the way you rationalize the denominator is you look at the radical expression in the denominator, and we're going to eliminate that by multiplying by itself. But you can't just multiply the denominator, you have to multiply the numerator too. We have to multiply by a form of 1. So we don't interfere with this expression as long as we're multiplying by 1. Now when you multiply the denominators, these two square roots of 5 turn into a 5. And on top, we're going to get square root of 6 times square root of 5, which is square root of 30. So in all, the 7 is still there. We haven't reduced or multiplied that yet, but we have multiplied square root of 6 and square root of 5 to get square root of 30. And then in the denominator, we have 4 times 5. Finally, I'm going to go ahead and multiply the 4 times 5 and get 20. Now, when I'm all done, I need to look at this thing one more time and see if there's any other math I can do. I can't reduce 7 over 20. That fraction is simplified. And I can't reduce the square root of 30 because there are no perfect squares that divide 30. So this thing is simplified and rationalized, and we're done. Let's take a look at another example. So here's a new problem, 10 square root of 2 over 3 square root of 6. I'm going to look at the rational coefficients to see if I can reduce those. I cannot reduce 10 over 3. I'm also going to look at the irrational coefficients, or the irrational values here, the radicands, and see if I can reduce those. As it turns out, I can reduce square root of 2 over square root of 6. They both can be divided by the square root of 2. So this one turns into a 1, and this one turns into a square root of 3. So I've just done my reducing. Let's see what's left. 10 times 1 on top, and 3 square root of 3 on bottom. This was my reducing. Always reduce first, right? Now we're going to rationalize. And to rationalize this, we're just going to look at this square root right here, the square root of 3, and we're going to multiply by the same square root. These guys make a 3. So on the bottom, I'm going to have 3 times 3. On top, I have 10 square root of 3. Right? When you do this math, you just write them next to each other. And then in the denominator, I can finish that off and write 10 square root of 3 over 9. And like we did in the last problem, just make sure you can't do any other reducing. Everything looks good. I can't reduce the square root of 3. I can't reduce the 10 over 9, so we're done. Remember, step 1, reduce. Step 2, rationalize. And then step 3, double check. Oops. Which we did. All right, let's just try a couple more just to make sure. So let's try and simplify and rationalize 7 square root of 32 over 7 square root of 40. I start off by reducing, and I notice that I can reduce my coefficients this time. In fact, 7 over 7 just reduces to 1, so those guys cancel out. I also notice that I can reduce 32 over 40. Both of those are divisible by 8. And so 8 goes into 32 4 times, so I have the square root of 4 here, and 8 goes into 45 times, I have the square root of 5 here. So I've done the reducing, square root of 4 over the square root of 5. But, actually, I haven't finished the reducing. Take a look at this guy. I know the square root of 4. That's just 2, so let's continue reducing. The more reducing you can do ahead of time, the easier the rationalizing will be. You'll save yourself work at the end. Now, with 2 over the square root of 5, I'm pretty sure I'm done reducing. So let's rationalize. And on top, we get 2, oops, that's the wrong marker. 2 square root of 5. And on the bottom, remember these guys just make 5. And then double check. Yep, everything's reduced. We're good to go. I'll put one more on and then we'll call this a video. So let's take a look at 3 square root of 3 over the square root of 8. Now, I only have one rational coefficient, so I'm not going to be able to reduce 3 over 1. I leave the 3 alone. And 3 over 8 doesn't reduce, so I can't really reduce the fraction square root of 3 over square root of 8. However, if I look at square root of 8, this thing is divisible by a perfect square. So I can rewrite this square root as square root of 4, square root of 2. So I'm simplifying that radical just on the bottom there, the square root of 8. And when I look at square root of 4, square root of 2, I realize I can do the square root of 4. So that's really a 2 and then a square root of 2. So when I rewrite this thing after reducing, I'm going to have 3 square root of 3 over 2 square root of 2. Oops, that is a 2. That looks better. All right, so this thing is now reduced as far as it can go. And we're going to rationalize now. So we're going to multiply by the square root of 2 down here so that this turns into a 2. And we have to also multiply by the square root of 2 on top. To finish this one off, in the numerator I have 3 times the square root of 6 because square root of 3 times square root of 2 is square root of 6. In the denominator, I have 2 times 2, and we know that's 4. 3 square root of 6 over 4. I think I'm done, but I'm going to just double check. I can't reduce 3/4. I can't reduce the square root of 6, so we're good to go. Okay, so this was just a video to remind everyone how to do that warm-up that we have in class where we're simplifying radical expressions and rationalizing the denominator. If you have any questions, you know where to find me. Take care.